Hello students, so hope you all are watching my videos regularly. And before starting our today's session, I'm just want to give some highlights of our previous lectures. That previously we just have completed logarithmic functions based on the complex variables, and we just completed that method. And as we have discussed in our previous sessions, that in my next session I will start my new method. We are going through the same part 1. I'm going to start one more new method, and the name of the method is circular and hyperbolic functions. So in this session guys, we are just going to go through the formulas of circular and the hyperbolic function. Let's start with the formulas. And first of all, it's a given of circular functions, and I think so. Starting guys, and here you can see that first of all it's given Euler's formula, and that is e raised to I theta, and by using e raised to minus I theta. Now these both components, the values of these both components you know very well, because this one we have did in our previous sessions of complex number. So e raised to I theta, it means we can write c theta, or else we can write cos theta plus I sin theta. And as well as for the minus I theta, we can apply cos theta minus I sin theta. Okay, so now taking addition of these both the functions, so that you can get a cos functions as well as sin theta, that is by subtracting the both components. So cos theta equals to, you can get the formula e raised to I theta plus e raised to minus I theta upon 2, and for the sin theta it will be e raised to I theta minus e raised to minus I theta upon the 2I. Okay, so these both are circular functions, and I'm also going to highlight so that you can get, because this one is very much important guys. So I'm just marking here this one and this one, this both you have to remember very well. Okay, now the next one is given hyperbolic function, and if x is real or complex, then hyperbolic cosine of x is defined and denoted as cos hx, and that gives you e raised to x plus e raised to minus x upon 2. This one you have already studied in first and the second semester guys. And same for the sin hx, then that will be e raised to x plus e raised to minus x upon the 2. Okay, so similarly the other hyperbolic functions are defined as, yani ki from these both functions, from sin hx and from the cos hx, you can write the other functions of the particular, so that it will be tan hx, yani ki sin hx upon the cos hx. And now putting the values of these both the functions, you will get this one for tan hx, and this one is it is for the cos hx. Okay, now first of all, listen carefully guys. This sin hx and cos hx, we are converting it into the real functions. So this is a very important formula for hyperbolic function. By using the hyperbolic, we can convert it into the real number also. Okay guys, now next one, you can see that here I have written the formula for sec hx as well as for the cosec hx. So here you have to just put the formulas of the given functions. Okay, now next there is given one table, and here it's given a value of the particular functions of z, yani ki we will find the sin hx, cos hx and tan hx. Okay, so for the minus infinite, 0 and infinite functions, so here you can write the sign of minus infinite will be minus infinite, sin h0 yani ki 0, sin infinite yani ki again infinite. Same term, this one cos sin hx into the minus infinite, this one same sin hz into the 0 and sin h, yani ki in place of z you have to put the values of infinite, 0 and minus infinite, and you will get this one, this all the values. And here as a note I have written one more function, that the sine of h minus z, yani ki the hyperbolic functions for the sine, and for the angle minus z it will be minus into the sine hz, and for the cos hz, for the hyperbolic function of cos and for the angle minus z it will be cos hz. It means it will be converted into the positive, and as you know sine is an odd function, so it will be minus of this function, and cos is an even function, so it will be converted into the positive sense. Okay, now I have written uh, before this I'm highlighting again guys, because these both are again important. In all the formulas I will highlight with the red mark and red or the yellow marks, and this one will be very much important and you have to remember this all the formulas. Okay, now it's given a relation between circular and the hyperbolic function. Okay, so here this one is very much important guys, and this one you have to remember that sin iz equals to I, yani ki circular function, the sin iz equals to I into the sin hz, and sin hz equals to minus into the I sin iz. And here I have given its proof, and proof is actually it's not coming in the exams, but for your information I have written, if anybody wants to do. Now next, it's given cos iz, and cos iz yani ki we can write cos hz. Again this one is important guys, and this one you have to remember that cos of iz yani ki the circular function for the cos will be the hyperbolic function of cos. And again here I have given its proof if anybody wants to apply. Now then after tan of iz, the circular function for the tan, and it will be I into the tan hz. Again guys important, and the next one is tan hz equals to minus I into the tan iz. So from circular we will apply, we will convert into the hyperbolic, and from by using hyperbolic functions we will apply it into the circular function. And again here I have given its proof. Now this one is also important guys, which I am marking with the red highlighters, and here it's written the sin hiz, it will be I into the sin x, cos hiz it will be cos x, and tan hiz equals to I into the tan x. Now rest of the formulas for the hyperbolic, which is based on the only hyperbolic functions studied in our previous session. That so in previous session I have discussed that we will do in our next session this all the formulas based on the circular or the hyperbolic functions. So right now I'm just talking about our previous slides, and as the last it's written cos h square x minus sin h square x equals to 1, right? And these all identities we have already did for the real functions, that sin square plus cos square equals to 1, sec square minus tan square equals to 1. So this is these all are the identities for the real functions, and right now in previous slide it has written for the hyperbolic functions. Okay, so for the hyperbolic cos square minus sin square equals to 1, then sec square plus tan square equals to 1, and cot square minus cos x square equals to 1, at where for the real function it was like cos x square minus cot square equals to 1. Okay, so these three formulas which is given into your previous slides, these all are very important. And now moving forward for this current slide, and here it's given results. So these all are the again very important. It's just for the information. The graph of hyperbolic of cos is symmetrical about the y-axis. The graph of for the sine hyperbolic function is symmetrical in the opposite quadrants. Now then after e raised to x equals to, we can write sin hx plus cos hx plus sin hx, and for the e raised to minus x we can write cos hx minus sin hx. Now sin hyperbolic of minus x, this one we did in our previous slides guys, and again I have written here. Now the derivative of sine will be cos hx, and the derivative of cos will be sin hx. Again this one is very much important guys. The derivative of sine will be cos and the derivative of cos will be sine. I hope you might aware from this both the formulas, because this one you have studied in the first and the second semester, as well as 6-1 also you have studied before this, that the integration of cos hx plus cos hx will be sin hx, and same the integration of sin hx will be cos hx. Now again there are some more formulas regarding hyperbolic, and here it's given the hyperbolic of sine, it will be 2 sine into the cos hx. For the cos it's same like cos 2 theta, sin 2 theta and tan 2 theta, and here it's given for the hyperbolic, so यहाँ पे क्या होगा, एक h add होगा. So this is a notation for the hyperbolic. So here it will be sin h2x, cos h2x, and sin tan h2x. So again these all formulas you have to do guys, and this one is for the 3 theta, sin 3 theta, cos 3 theta, tan 3 theta. So this one again you have to remember this all. Now next it's given that sin of x plus y. Okay, ये वाली फॉर्मूला भी हम लोगों ने पहले की है, like sin of alpha plus beta and sin of alpha minus beta. So same we will apply it for the hyperbolic. Then sin hyperbolic of x plus or minus y, same cos hyperbolic of x or minus y, and for the tan hyperbolic of x or minus y. So again you have to do this all the formulas. Now next one, s plus s, then after s minus s, then after c plus c, and then c minus c. Okay, so पहले हम लोग रियल नंबर्स के लिए कर रहे थे, अभी आपको करना है फॉर दी हाइपरबोलिक, तो यहाँ पे क्या होगा, h ऐड हो जाएगा. ओके, नाउ वन मोर साइन h प्लस यानी कि s प्लस s, सेम s माइनस s, c plus c, and as well as c minus c. Okay, now then after inverse. Okay, so guys here the functions are given, whatever the functions are given we are going to find in our next session. Okay, these all the formulas we will prove by using its formula, like sin h inverse equals to sin h inverse x equals to how we are getting log x plus under root x square minus 1. So ये सारे के सारे functions के हमें proof है हमारे पास, वो and वो हम लोग कर रहे हैं in our next session. Okay, so right now just you can remember these all the formulas, like cos inverse for the hyperbolic will be log of x plus under root x square minus 1, like this way. So again these all the formulas we are going to prove in our next session, and that are very much important for the exams also. Now next you can see here it. So there are given so many sums regarding this based on the given formula that we did in the last slide, but that we will do in our next session. So till that, please remember this all the formulas and note down it in your lecture notes also. Thank you guys.